Hi everyone, welcome back for another episode of SIAM Speaks. And today we have with us Mr. Timo Unger, if I'm pronouncing it right.
Yes, you do.
He is one of the leading experts on recycling in Europe. And if you could please introduce yourself for our guests.
Absolutely. So, hi everyone, I'm Timo. I'm working since 20 years for Hyundai Motor Company in the broad field of sustainability. So it's not just circular economy and recycling, it's going beyond. I even have studied recycling technologies at university in Germany back in the 90s. And with this experience, I'm now really happy to see that all of these topics are more emerging ones and that more and more people are getting interested in that.
Okay. As they say, need is the mother of invention. I think need is the mother of focus also, because it has become a need for us to look towards circularity. That's why people are looking there. So if I could start with the first question.
Sure.
The first question that I wanted to ask was, since we are here at an automotive field, and in an automotive field, what kind of challenges would be there for a vehicle manufacturer, for a vehicle OEM, to truly design a truly circular and sustainable vehicle?
Oh, that's probably the question of the questions, right? And I would wish I would have an answer, but I will try to do my best. So, from European perspective, there's a strong pressure on vehicle manufacturers to become more sustainable. This pressure is coming, first of all, from legislation. So in Europe, we have the Green Deal, which is now transformed into the Clean Industrial Deal. And this consists of a lot of regulatory files, such as the end-of-life vehicle regulation, which is currently drafted, the eco-design for sustainable products regulation, we have the battery regulation, we have the Critical Raw Material Act. So we have many, many more legal requirements that are pushing us into a direction which means become more sustainable, become more circular. At the same time, we also have increasing pressure from our customers, which are expecting us also to become more sustainable. However, according to market research that we did, we have realized, unfortunately, that our customers are not really willing to pay more for the sustainability and circularity of our products. And this is a big challenge because not always. There are great exemptions to the golden rule, but the golden rule is very often, unfortunately, sustainable solutions, technical solutions are a bit more costly than the other ones, right? And this brings us into a very challenging situation because on the one hand side, we would like to become more sustainable. On the other side, we have also that economic push to be successful. So now there's the question, what is sustainability? And I think this is a very difficult question to answer. So I give you an example, and this example is a carbon fiber reinforced vehicle component. My question usually here is this sustainable or not? What do you think? Is it sustainable? Carbon fiber reinforced plastic part.
So if I may, I have a limited understanding of this kind of topic, especially in terms of carbon fiber. But I think from mileage and fuel usage point of view, since it's lighter, it might be more sustainable. But please.
That's a fair answer indeed, but it's unfortunately not so easy.
Okay.
Because such a carbon fiber reinforced plastic component, for example, is pretty good in terms of lightweight. And lightweight means energy reduction, means fuel reduction, means CO2 reduction. So this is good, great achievement towards sustainability. But the recyclers, they hate it. They don't want carbon fibers in their plastic waste streams.
Okay.
If these fibers are shredded, there is dust generated. If you inhale the dust, you may even die of cancer. So it's even from a toxicity side critical. On the other side, it is very sexy. So carbon fiber parts are pretty good because our customers, they appreciate that.
Correct.
And sexiness is a very important part of sustainability, because only if you manufacture sexy products, you can sell them, and only if you sell them, you are successful. If I manufacture something which is not sexy, I manufacture that to be wasted. So in order to be sustainable, I have to reduce my carbon emissions for the product. I have to increase the circularity of the product. I have to decrease the toxicity of the product. I have to take care of ESG topics such as supply chain due diligence, no child labor, no modern slavery involved, and my components have to be sexy. And the problem is, and with this very simple example of a carbon fiber reinforced part, I tried to show you that for a vehicle manufacturer or a manufacturer of any other component, by the way, right, it's very challenging because we have trade-offs. There are legal requirements that are pushing us into a direction of becoming carbon neutral, becoming circular, but these different objectives are contradicting. There are trade-offs generated, and for us, it is super, super difficult to overcome these challenges and to find a right decision and a right strategy. What makes it even more problematic is the point that our components are highly durable. Durability is something good, don't get me wrong. Very often people are saying, hey, a sustainable product is a durable product because it stays longer on the market. You don't need new things. The manufacturing of new things, they cost energy and resource and whatsoever, so just keep it on the market, which is true. This is a very fundamental dimension of sustainability. But when it comes, for example, to circularity, durability is something very bad.
Correct.
Because if we manufacture today our products, and if we would like to make them, for example, recyclable, we call that design for circularity. We would need to understand the recycling technology in 20 years. But how to do that without having a well-working crystal ball? This is not existing. So how on earth are we supposed to do the right things without knowing how to address the trade-offs and without having the crystal ball that helps us to understand the recycling processes in 20 years? Because this is exactly when our vehicles that we design today will
actually come to the recycling lot.
To the scrap yards.
Correct.
So in 20 years from now, so we would need to know the technologies in 20 years in order to address them today in our vehicle design. We don't know that, and therefore we are lost, because different to a milk bottle manufacturer or a water bottle manufacturer or some packaging and other short life products, for them it's easy. They can do it. And now there's coming another very critical dimension. And this is also related to the durability point. The hazardous, or let's say the amount of hazardous chemicals that are contained in our products. So what you should know is, if we place today a car on the market, these cars are compliant. They are compliant with all the substance restrictions that we know somewhere in the world. There is UN Stockholm Convention that is requiring us to get rid of hazardous chemicals globally. There is EU REACH, there is TSCA in the US. There is quite a lot of chemical regulation. And when we place our cars on the market, we comply with the current status of that regulation. Now the car is driving on the road for 20 years.
Correct.
After that, the car is being recycled. And we are now forced, for example, to do closed loop recycling. That means take the plastic out of the car and put it back into the car.
Correct.
That doesn't work. Not for durable products such as vehicles. Why that? Because within these 20 years, the hazardous chemicals that were not hazardous when we have manufactured the cars have become hazardous, probably because of a new regulation 10 years after placing on the market. So suddenly, a chemical which was not a problem has become a problem during the vehicle use. And now we have to take that vehicle, we have to take that plastic in order to recycle it in the closed loop. We are not allowed to do that because suddenly these hazardous chemicals are contained. right?
Correct.
So, and this is just a bit of examples on how and why it is so difficult for vehicle manufacturers to do the right thing. It's not that we don't want, it's simply that there are no tools, there are no crystal balls existing that enable us to do the right things today.
No, I completely agree, Mr. Tim. Actually, I have a follow-up question on that. Uh, you have told us a lot about the materials and their long-term sustainability, right? In terms of processing, in terms of recycling, like there needs to be a, since we don't have a crystal ball, we just, what I assume is that we need to have a longer sense of planning. Now, from a strictly European sense of view, what are the current lightweighting and from a material point of view, what are the current lightweighting and sustainability materials being used for this specific purpose? Are there any examples? Are we somewhere along the lines?
I'm not the expert on lightweight, to be very
Okay.
honest, right?
Okay.
So I cannot give you some real insights into the latest developments on
Okay.
lightweighting solutions.
Okay.
But I think that's not so much the question here, right? The question probably is more, so what are we doing in terms of sustainable substitution?
Correct. Sustainable substitution.
And sustainable substitution is a very important part. The background of all that is chemical legislation. Mainly in Europe, for example, EU REACH, there is now a very dark cloud at the horizon, which is called the PFAS restriction. Not sure if you have heard about PFAS. So this is perfluorochemicals that are highly persistent, that are carcinogenic, that are toxic, that are really troublemakers. But at the same time, they have a very, very good technical performance.
Okay.
So around 15 to 20% of all vehicle components, according to our latest assessments. And if I say our, that doesn't mean necessarily Hyundai. It's more, I'm doing a lot of association work, so that's more an association number. But around 50 to 20% of all vehicle components are somehow directly or indirectly impacted by that PFAS chemicals, right?
Okay.
They are used in batteries, they are used in fuel cells, they are used in plastics. The Gore-Tex jacket is PFAS. The anti-sticking pan, this is PFAS, Teflon. We have them in lubricants. We have them really in many, many applications. Without PFAS, a vehicle would not work. Now coming to substitution. We are forced to substitute these PFAS, or we will be forced, the law is not enacted, but we will be forced, and that makes total sense because these chemicals are bad, right? So we have to substitute them. But again here, it's not so easy because what is the right thing? If we would replace PFAS in batteries, the alternative would be lead acid batteries, for example. There's no PFAS contained.
Correct.
But this would decrease the performance of the battery so much, that would increase the weight of the battery so much, that would lead to the situation that we would fall back into the Stone Age in terms of other sustainability indicators, right?
Correct.
So again here, we would like to do the right things. We would like to do sustainable substitutions. But we don't know how, because it's very difficult, because we may buy in a trade-off by getting rid of that and then having less sustainable products at the end. So it's really a question on how to handle that, how to deal with that. And this over the full life cycle of the vehicle, starting with the production and ending with the waste stage. And this is one, let's say, parts of the solution. At the waste stage, we have to make sure that there is not much exposure of such hazardous chemicals into the environment.
No.
Does that answer your question a bit?
Yeah. It answers my question to a great extent.
Yeah.
So I actually don't have any further questions.
Good.
And thanks for this truly enlightening session for us and for our viewers. So once again, thank you, Mr. Tim.